Good afternoon, class. Here's elementary statistics, practice test number 3, module 3, covering chapter 6 and 7. Chapter 7, estimating parameters and determining sample sizes. Again, reminding you of the pledge when we take the exam. I pledge on my honor that I will neither give nor receive unauthorized assistance, so on and so forth. You may use formula sheet, tables, and a graphing calculator. Okay, let's get started. Answer the following: true or false. The confidence interval estimate of the population mean is constructed around the sample mean. Yes, because the formula X bar plus minus E. CI, short for confidence interval. Now, sigma of X bar is sigma over square root of n, and E is Z alpha over 2 sigma over square root of n. That's how you calculate the E. Estimation means assigning values to a population parameter based on the value of a sample statistics. Please understand, everything we do in statistics is about population, but everything is about the population. So we have access to only samples. So we use sample to get to the population. The confidence level is denoted by 1 minus alpha times 100%. The maximum error, also known as margin of error of the estimate for mu based on known sigma, is the formula that you have here. E equals Z alpha over 2 sigma over square root of n. The parameter of a t-distribution is degrees of freedom, which is equal to n minus 1. What criteria, question number 2, are required to apply the t-distribution to make a confidence interval for mu? So we normally use the z-distribution. In some instances, we use the t-distribution. When would that happen? Number 1, the sample must be a simple random sample. Number 2, either the sample is from a normally distributed population or n is large. How large? Larger than or equal to 30. Population standard deviation sigma is unknown. It's missing. We don't have that. Sample statistic is used as a point estimate, which is a specific numerical value estimate of a parameter. A point estimate is a single value or point used to approximate a population parameter. Example, the sample proportion P hat is the best point estimate of the population proportion P. For confidence interval, we can use a point estimate to construct a confidence interval estimate of the true value of a population parameter. T-score, find the values for T for a T-distribution with a given sample size and a confidence level. Well, when they give you the confidence interval in between, you have 90%, 95%, so on and so forth. And the two tails contain the rest of it. So for example, if this is 90%, that means 10% in both tails, that means 5% in each. So as an example, if this is 90%, then this must be 10% divided by 2 or 5%. And so is this. That's the meaning. So what you do this is a T table or T distribution. In the left column, you look for degrees of freedom, which is n minus 1. Then at top, for example, confidence interval, you look at the area in two tails, for example, 10%, 5%. But if it's a one-tail test of hypothesis, then the area in one tail, and you connect them, the point of intersection is the answer. That's how you look them up. Find the value for T for a T distribution with sample size of 20 and a confidence level of 95%. Needless to say, we can use technology as well, but using the table, we are dealing with a 95% confidence interval. Smack in between. So this is 5% divided by 2, or 2.5% or 0.025. Same thing here, of course, right? Because if 95% is in between, the rest of them 5% is in both tails. They're identical, so half and half on each side. So you have the table. And again, for limitation of space, I don't have all the degrees of freedom, but we have most of them. And degrees of freedom here is n minus 1, which makes it 20 minus 1, which makes it 19. So we look for number 19 here. In here, we look for number 19. Now, because it's a 95% confidence interval, the two area in two tails is 5%. So area in two tails is 5% or in one tail. So you look for that. And they have an intersection of 2.093. So this is negative, this is positive, 2.093. So you have two answers. That's how you find from the table. Find the value of t for a t distribution with a sample size of 30 and a confidence level of 90%. So now this is 90%. So this is 10% divided by 2. So each side is 5%. The tails, 10% divided by 2 on each side. Degrees of freedom is n, 30 minus 1, it makes it 29. So over here, we look for number 29. Up here, area in two tails is 0.1, in one tail is 0.05, and the intersection of the two gives us 1.699. So this is negative, this is positive, so plus minus 1.699. This is how we find the value of t from the table. However, if we were to use technology, for example, TI, we would go with second variables inverse t, and we put the two entries, left area and degrees of freedom. So area on the left is inverse t, 0.05, degrees of freedom is 29. And of course, the answer that you get here is this one, everybody. And you should recognize there are two answers. And of course, technology gives you a lot more decimals, and you have to round it accordingly. That's important to understand. We already have discussed the calculators online. These are a couple of calculators for t distribution. You can use them as well. If you use Excel, basically uses the same methodology. Find the t-score, use t inverse. Two entries, left area and degrees of freedom, enter. All right, find the chi-square value for 20 degrees of freedom when the area to the left is 0.01. So chi-square, what about that? First and foremost, the chi-square distribution must be used to calculate confidence interval for variances and standard deviations. The chi-square variable is similar to the t variable in that its distribution is a family of curves based on the number of degrees of freedom. The symbol of chi-square is chi-square, Greek letter chi, pronounced chi. A chi-square variable cannot be negative, and the distributions are skewed to the right. So it's skewed to the right. And so what we need, we always need the area to the right and degrees of freedom, which is n minus 1. In this case, degrees of freedom is given, so you don't have to subtract 1. Area to the left is 0.01. But we need degrees of freedom, we have it. And the limitation of the table is that we need the area to the right. By the way, I don't have enough room, so I put up to 7, and then we add another one in a moment. So we need two things, degrees of freedom, area to the right. If the area to the left, in other words, it looks like this. This area is 0.01. So what is this area? You need the area to the right. A sub r is 1 minus that, 0.99. So chi-squared of the left area being 0.01 is the same as chi-squared of the right side. So left area is 0.01, right area is 0.99. You want to look it up here. So we need degrees of freedom of 20. So we locate the 20 here. Okay. And up here, the area to the right is 0.99. So locate 0.99. So this is 20, this is 0.99. Their intersection, 8.260 is the answer. So you can write, let me erase my work. Chi-squared, the left area is 0.01, or chi-squared, the right area is 0.99, is this number 8.260, of course, with the degrees of freedom of 2. What about the critical chi-square value for any co-study, and the area to the right is 0.9. So we need two things. We need degrees of freedom, so n minus 1 or 29. We need the area to the right, it's given. So degrees of freedom is 29, area to the right is given. So we locate number 29 along the first column, we get here. And then over here, the top row, we look for 0.9 is here. And the intersection of these two is 19.768. So chi-squared when the right area is 0.9 is the same as chi-squared when the left area is 0.1. Remember, these two must add up to 1. The total area under the curve represents the area. So the total probability, 19.768 is the answer. A statistician is interested in estimating at a 95% confidence level the mean number of houses sold per month by all real estate agents in a large city. It is known that the population standard deviation is 1.9. How large a sample should be taken so that the estimate is within 0.65 of the population. So first and foremost, let's see what is given. We want a 95% confidence interval. Population standard deviation, sigma is 1.9. Within this estimate makes it the value of, so 95% confidence interval. Sigma is 1.9, is 0.65. Now 95% confidence interval. I'm going to remind you of the following formulas. Confidence interval for the mean is x bar plus minus e, where sigma of x bar is sigma over square root of n, e is z alpha over 2, sigma over square root of n. So if you concentrate on this one and solve for n, that means first let's square both sides. E squared is z squared sigma squared over n. And if you solve for n, you get this formula. In other words, in this formula, find n. So this is what the question is asking us, find n. So we need the z sigma e. We have everything, and z comes from the choice of confidence level of 95%. It is a common one, so you could memorize the formulas, the numbers. The z value for a confidence interval of 95% is plus minus 1.96. Each tail contains 5% divided by 2, or 0.025, 1.96. So we're going to plug in, we have everything. (1.96) times sigma, which is 1.9, divided by 0.65 to the second power. Now, it will always be a discrete value, a whole number, and it must be rounded up. First, I want to make sure everybody understands what this means. This means this is the minimum sample size we need. So it will have to be rounded up. Whether it's 32.8 or 32.1 makes no difference. You round it up to 33. By the way, there may be a slight difference if you use the technology because technology uses a lot more decimal. Okay, that's why. Find this 95% confidence interval if the mean for such sample size is 3.4. Well, X bar is given as 3.4. We want X bar plus minus E. So that means 3.4 plus minus 0.65. Okay, so here's X bar plus minus E, X bar minus E less than mu, less than X bar plus E. So this is one way to report it. The other one is to subtract 0.65 from 3.4 and add it here and report it in this manner. Now, which one do you report? If you want to get full credit, you better pay attention to the way they ask you. They may want it in this format. They may want it in this format. Which one is the answer? Whatever they ask you. So be very careful. What does it mean? We are 95% confident that the true population mean is between 2.75 and 4.05. That is really the meaning of a confidence interval, everybody. So that's pretty straightforward. A random sample of 20 female members of a health club showed that they spend on average 4.5 hours per week doing physical exercise with standard deviation of 0.75 hours. Assume the time spent on exercise for all female members is approximately normally distributed. What is the value of point estimate of the population mean? And so on. Okay, so first and foremost, understand what is given. So as we read this question, they are telling us that it's normally distributed. N is 20, and 4.5 is the average for those 20, so that's X bar, not mu. Okay. And the standard deviation for that, for those 20 female members, is 0.75, that's S. So that's understanding the given. The point estimate for population mean, mu, is always X bar. Is X bar given? Yes, 4.5, that's your answer, and you're done. $4.5. Construct a 98% confidence interval for the mean time spent on physical exercise of all such females. Reminding you the formula is confidence interval, CI, short for confidence interval, is X bar plus minus E. And because sigma is missing, S sub X bar, S over square root of N, is T alpha over 2 S over square root of N. That's how it works. So when we look at this formula, we have X bar, and we need to calculate E, which is S over square root of N, and then multiplied by T, and the 98% confidence interval will help us find it as follows. So we have a 98% confidence interval. That means alpha, the tail, is 2% or 0.02. So this is 98%. This is 2% divided by 2.01, 0.01. So the tails, they add up to 0.02, but each one is 0.01. So we need degrees of freedom because X bar plus minus, if we want to find all of those, we want to find the critical value. N is 20, degrees of freedom is N minus 1 or 19. So we can find the t either from the table or technology, and it gives us plus minus 2.539. X bar plus minus E, where E is T alpha over 2 S over square root of N. So the first thing we need to calculate is the E, and we have everything. This is 2.539. S is 0.75. Square root of N is 20. Plug in, do the math, and now there are two ways to report it. This is one way, if they ask you to report it in this format. The other one is that mu is between the two numbers, 4.5 minus this and 4.5 plus that, which gives you the following. It's extremely important to understand that there are two different ways of reporting this, everybody. This is fine, so is this. Which one do you use to report whatever they ask you? So if I were to use a TI command, okay, a calculator, stat, test, the interval, enter the data as follows. So we're going to put T interval, X bar, we have to put the value of X bar, 4.5. S, the value of S is 0.75. N, the value of N is 20. And what do we want? 98%. 0.98 is the confidence level. When you do the calculation, you get the value that you have here. Now, what does it mean? Of course, you know, this is slightly different due to the fact that they use a much more precise answer when they calculate this, okay? And so having said that, it means we are 98% confident that the true population mean is somewhere between the two numbers, 4.0742 and 4.9258. Out of 500 randomly selected adults, 300 said they were in favor of the death penalty for a person convicted of murder. What is the value of the point estimate of the population proportion? Clearly, we are dealing with BD, binomial distribution. N is 500, X is 300, so that's important to write the given. And point estimate of P is P hat, and P hat is X over N. So 300 over 500, which gives us 3 over 5 or 0.6. Both of them are exact numbers. So that's a point estimate. This is where we start to develop our confidence interval. So what is the 95% confidence interval for the population proportion? I'm going to remind you of the formulas as you have them in your formula sheet. Confidence interval P hat plus minus E, similar to the mean. Mu of P hat is P. Sigma of P hat is square root of PQ over N. When we don't have P and Q, as we don't have it here, then we use the square root of P hat Q hat over N, and E becomes the alpha over 2 square root of P hat Q hat over N. So I hope everybody is okay with that. All right. So we are ready to use the formula. What about 95% confidence interval? Remember, binomial distribution, if NP and NQ are large, and this is the case, you can try it. You can multiply N by, P hat in this case to see it's large, and it's way larger than 10. It is approximated by normal distribution. T is an approximation of Z. Therefore, one approximation is bad enough. We never ever use the T. We always use Z in the case of a binomial distribution. So having said that, E is Z alpha over 2 squared of P hat Q hat over N. And so we have everything. What is Z? 95% is a common value. Q hat is 1 minus P hat, which makes it 0.4. This, as we mentioned, is 1.96 is a common value. So now we have everything plug in. Evaluate, we get 0.0429. So the answer is p hat plus minus e, which is 0.6 plus minus this number, or 0.6 minus this, 0.6 plus this, p is in between. So this is one way to write it. In fact, box that. So this is one way to report the 95% confidence interval. The second one, 0.6 minus this number, 0.6 plus this number. So p is between these two. This is the second method. Again, which one do you use to report? Whatever they ask you. They may ask you for this or that one, not both. So as far as the technology or TI calculator is concerned, the stat one proportion z interval. So take a look. One PROP, proportion z interval, x 300, n 500, confidence level 0.95 or 95%. And take a look. Okay, 0.5571. So if you stop here, 0 changes to 1. 0.6429, 0.6429. If you stop here, 9 doesn't change. So extremely close. What does it mean? We are 95% confident that the true population proportion is between 0.5571 and 0.6429. How large a sample is needed to be 99% confident that the margin of error is 0.025 for percentage of golfers that are left-handed if we assume that 15% of the golfers are left-handed based on a previous study. So, reminding you of what we know about confidence interval for P, which is P hat plus minus E. Here's sigma of P hat, here's E. Now, again, in this formula, if you square both sides, you get E squared. This is Z squared, P hat, Q hat, N. And if you solve for N, you get this one. So you really, that's the justification for that. Okay, so that's why I'm giving you this formula. So assume 15% based on a previous. So we want to do that. And first of all, what is given? Okay, so we are assuming this is 15%. That means P hat is 0.15. Okay. And what is given is a 99% confidence interval with the E of 0.025. And in this case, P hat is 0.15. So let's write this and erase my work. So 99% confidence interval is 0.025, and we are assuming P hat is 0.50. Now, 99% also is a common confidence interval. So this is 99%. That means 1% in the two tails. That means 1% divided by 2 in each tail. Okay, so I want to make sure everybody understands what's going on here. So 1% 0.01 divided by 2 means 0.005. This is the area on each side, each tail. Common value, and the z-score is minus 2.57 plus 2.57. Okay, so wanted you to see that. And so confidence interval of 0.99, z is 2.575. Let's plug it into this. Into this goes the z value, p hat is 0.15, q hat, of course, is 1 minus that. So let's calculate the q hat first. So we have everything, and just follow the given, everything here, plug in. 2.575 quantity squared, 0.15, 0.85 over 0.025 quantity squared. Make sure you square that, because I've seen that mistake. And we get this answer. Now, as always, we round up because this is the minimum size that will do the job. So you have to go with the whole number and go up to 1,353. Again, regardless of what you have here, it's 0.6 or 0.1 makes no difference. Now, assume that we have no prior information suggesting a possible value of the sample proportion. So what happens if we don't know about this 15%, everybody? We assume P hat and Q hat are equal and equal to 0.5, and that is the worst case scenario. The number we come up with definitely is larger than that. If we don't come up with a larger number, we made a mistake somewhere. Okay. Now, if you go back to this formula, so in some formulas, you may see instead of that, for a case like this, they would put 0.25 because the product of 0.5 and 0.5 is 0.25. All right, so we have the confidence interval of 99%, Z is 2.575, E is 0.025, P hat and Q hat are 0.5, so that's what we put in. So again, in some cases, they just fill in the 0.25. Put it into a calculator. 2.575 squared times 0.25 times 0.025 quantity squared gives you this one. And as I mentioned, we round up. This is 0.2. It doesn't matter. This rounds up to 3 because this is the minimum size n we need. So we have to have a discrete value, a whole number. We take it up, 2653. As I mentioned, always round up, always. Again, in between or here, it's the confidence interval. Those are the two tails. Given n is 30, x bar is 80.5, s is 4.6, assume normal population, find 98% confidence interval for population variance and standard deviation. There's really nothing to write. Everything is given symbolically. All we have to do, find the confidence interval. So what is the formula? For sigma squared or variance, okay, it's in between n minus 1 a squared over chi squared of right side, less than n minus 1 s times a squared over chi squared of the left side. As far as the standard deviation sigma is concerned, when you calculate this, all you have to do is take a root. So having said that, we want to calculate this, and we need n, it's 30, it's given. We need s is given. We have to figure out the chi squared of the right and left, and it comes from the choice of 98% confidence interval, degrees of freedom of n minus 1, which is 29. So confidence interval, 98% here. That means 2% in two tails. Each one is 1%. Okay, so degrees of freedom is n minus 1, 30 minus 1 is 29, 98% confidence interval, 1 minus that is 0.02, which gives us 98% or 0.98 in between, and 2% divided by 2, 0.01 in each tail. So, and remember, in order to read the chi squared, we need two things. We need degrees of freedom, which is n minus 1, 29. So on the left side, you have to locate the degrees of freedom. It's not a big deal. It's very straightforward. Okay. And we also need the area to the right. Okay. So for this one, chi squared of the right, the area to the right is 0.01. For this one, chi squared of the left, the area to the right is 0.99. I want you to see that, okay? So having said that, chi squared of the right, area to the right is 0.01. So 0.01, 29. Intersection of the two is the answer. 49.588 is chi squared of the right. Very straightforward. Done with that. Now for the left, chi squared of the left, area to the left is 0.01. So what is the area to the right? 1 minus that, or 0.99. We need degrees of freedom. 29 is already there. We've located it. And at top here, top row, we look for 0.99. So we put these two together. The point of intersection is the answer, 14.257. So having said that, into this formula goes everything we've got. N minus 1, of course, is 29. S, 4.6 squared. So that's the numerator for both cases. Now, chi-squared of the right is this number, put it here. Chi-squared of the left is this number, put it here. I put that into a calculator. Chi-squared is between the two. So if they are asking for the variance, here's the confidence interval for the variance. And we're done with that. For standard deviation, all you have to do, take a root. And however many decimal they ask you. This is the confidence interval for standard deviation sigma. What does it mean? We are 98% confident that the true population standard deviation is between the two numbers, 3.5178 and 6.5606. That's the meaning of a confidence interval.